Hi, this is Mrs. Cribb, and this is the tutorial on naming acids. And it's only going to be on this really short section of your notes, 8.12 and 8.13. But I want to do a quick reminder of the polyatomic ion. So I'm going to scoot up. So you probably need to stop and pull out your notes. And I'm going to scoot up to the polyatomic ion section. With the oxyanions, there they are. And let's see here. Oxyanions right there, and they contain oxygen, and the pattern that we see with these is per something 8, 8, ite, and hypoite. And so remember, this is the per 8 oxyanions. That means negative. Anions, remember, are negative. The per 8 ones have the most oxygens in them, maybe 4. And then the 8 has one less, which would be 3. Ites have 2. And hypoites have only 1. And so we named this one over here, and this was sodium. There's the sodium. And sodium. And the SO4, which I want, is one of the ones you have to memorize. It's on your polyatomic ion list, is sulfate. Sulfate, the polyatomic ion. When you see an atom, or a molecule, or compound rather, with 3 types of atoms, sodium is one, sulfur is one, and oxygen is another one, then you probably have a polyatomic ion. And this one was magnesium. There's the Mg. Magnesium. And then NO2. And if you looked on your polyatomic ion sheet, I'm going to see if I can pull that up real quick. There we go. There's the oxidation chart. And this is the polyatomic ion sheet that you have. I look down and find NO2. Well, I don't have it. I have NO3, which is nitrate. See that ATE? Nitrate, and it has a -1. So if it goes per 8, 8, ite, hypoite, then nitrite would be 1 less than nitrate. So let's go back to the thing here. So what I saw on the polyatomic ion sheet was NO3 with a -1 charge, and that was an 8. And according to the pattern, one below it, which would only be 2 oxygens, this one has 3, this one has 2, would be an ite. So nitrite then would be NO2, 1 less oxygen, and it has the same -1 charge. So these are the endings for the polyatomic ions, 8s and ites. So this one was magnesium nitrite. Magnesium has a +2 charge and nitrite has a -1. Swap and drop. So the 2 goes down here. That's where that formula came from. And then these are just 2 polyatomic ions. And when you see 2 polyatomic ions stuck together, you just name them. So this one is the ammonium ion, and this one is bromate. And I'm going to double check that one, both of them. Okay, ammonium is one of the ones you need to know right here, and these are all in alphabetical order. That's why I like this chart. Ammonium is NH4 with a +1, and then that was bromate, BrO3 with a -1. Now bromate has bromine in it. So see that? Bromate, bromine, and then 8 are the oxyanions. And then chromate has chromium, and it has 8 as oxyanions. So now we reviewed that. This one down here, potassium dichromate, I'm not going to worry about because we have gone over these before. So what I want to do now is skip down to the binary and ternary acids. What I'm going to do is explain this and then pull up, actually I'm going to have to make another short video with the homework on it because I can't look at 2 PDFs at once and write on them. So these are the binary acids. Binary, remember bi means 2, so it should have only 2 types of atoms. They're covalent compounds beginning with hydrogen, and the acids consist of hydrogen and one other non-metal, and they're called binary. So they have 2 things. They begin with hydrogen and they have just one other non-metal. That makes it a binary acid. Now, when HCl is a gas, that means it's not mixed in water, because acids, this is when they are fluids, or sorry, when they are liquids, they are named differently. So when HCl is a gas, that's not a liquid. So we name it then as just hydrogen, and then that's chlorine chloride, or hydrogen monochloride. One of those. I think I've seen it both ways. They're both nonmetals, and so covalent, so monochloride would be the more right thing. Remember, covalents use prefixes, but ionics can use Roman numbers. Okay, so if you have just hydrogen at the front and a nonmetal, you just name it like that. But if it's dissolved in water, that makes it a liquid. It becomes an acid. And this is where things change. If it has just hydrogen and just chlorine and it's an acid, then it's hydrochloric acid. You say hydro something ic acid. Hydro, like in the water. So it's acid in water. Hydro something ic acid. So HCl would be hydrochloric acid. All right, so if I just have HBr, that's still binary, two things, hydrogen and bromine. And if it's in water, so it'd be HBr and it would be aqueous, AQ, meaning it's dissolved in water. Then this would be hydro something ic acid, and so hydrobromine, bromic. You change it to ic. So this is hydrobromic acid. And if it's HF, still binary, one, two things. So that would be hydro something ic. Well, this is fluorine, so it's fluoric acid. Okay, so fluoric acid. All right, so the binary ones are pretty easy. It's the ternary ones that's going to give you a little bit of trouble, but not too much. This is because they deal with polyatomic ions, so you got to get that pattern again. Let's write it down. Per 8, 8, ite, hypoite. Okay? All right, now with these acids, they're going to contain hydrogen, oxygen, and another nonmetal. Hydrogen will be at the front. There it is, see? And then basically what we do is we have a polyatomic ion. And so we're going to name this acid based on that polyatomic ion. Okay? Now this was hydrobromic acid. Well, if it's not hydro, I mean, these right here is, it's not going to have that same hydro something at the front. Okay, anyway, sorry. HBrO4. Okay, we need to name this according to the polyatomic ion. So we got to look at the polyatomic ion sheet. And let's BrO4. Well, we have BrO3 right here, and that's bromate. So what do you think BrO4 is? And it actually is one that you're going to have to know. So, oops, I hit the wrong button there. So BrO4, instead of being bromate, should be perbromate because it has more oxygens than bromate. Remember, there's the pattern. So BrO3 minus 1 was bromate. This has one more, so BrO4 minus 1 would be perbromate. So this is perbromate, this polyatomic ion thing right here. Perbromate. Now, that's the name of the ion, but that's not the name of the acid. This is how we name the acids. All the things with an 8 ending, we change the 8 endings into ike endings. And all the endings that are ite, we change 8 to ix and ites into us or us's. And I like to say it like this. Adic-itis. Say it fast. Adic-itis. Adic-itis. It sounds like a disease, and I can remember it easy. So 8 becomes ick, ite becomes us, and you could go backwards. Us becomes ite, and ick becomes 8. 8 becomes ick, ite becomes us. Adic-itis. So this is an 8. So perbromate becomes perbromic, and then we put the word acid at the end. So ick acid. So 8s become ick acids. Ites become us acids. All right? So let's practice a little bit more. Oh, look, that's the only practice here. Okay, I'm going to stop it, and I'm going to pull up the naming acids worksheet And I'm going to actually have to make another video, so you're going to need to open up the next video on the naming acids worksheet so we can go through some more examples together.